Welcome to binary tree operations. In binary tree, we can perform insertion operation, deletion operation, and searching a particular data from the binary tree and visiting all the elements using traversal, and some of the auxiliary operations to find the height of the tree and level of the tree and number of elements available in the entire tree. First we will see how to insert the data into binary tree. So here the data will be stored inside the node. Suppose if it is the 10, means the 10 is the node which is having the structure as we discussed in the previous video: data field and left child field and right child field. So this is the structure of each and every node in the binary tree. Here first we have to create the queue data structure, then we will check the tree is empty or which is having any other nodes. If it is empty, the new node which is going to created going to add as a root of the tree. If there is empty tree, then the new node will be added as a root of the tree. Otherwise, if the tree is having already some number of nodes, then we have to add that root node into the queue data structure. So now one has to be added into the queue data structure, and we will create one variable temporary that represents the current node representing the current node. First we have to check whether the current node is having left child and right child. Yes, now current node is the q. So this current node is the one. The one is having the left and right child. So left child is 2, right child is 3. If the current node is having left and right childs, okay, we have to add that both children into the queue. So 2 also entered into the queue and 3 also entered into the queue. But if my tree is not my tree is having only the root, okay, my tree is having only the root. It is not having left child, and if it is not having left child, then the new node will be added as a left child. Okay, suppose if my new node is 10, means the new node will be added as a left child to the root. Suppose my tree is having left child already, this is 1, this is 10. Already my tree is having root is having left child. If left child is present, then add the new node which is going to be inserted as a right child. We are going to insert the new node as a right child. So this is the new node now. So this is the procedure to insert the node into the binary tree. We will write Java code here. We will call the method insert by passing the root node and data. Suppose I am having the I am having empty tree. Okay, now as of now my tree is empty. I don't have any node in the tree. So now I am passing root value is as of now null, because I don't have any root node. So here it is null. So null value I am passing as a root, and I am going to create one node with the value 10. So data is 10, root is null. Now I am creating one temporary variable current underscore node which is null, and temporary uh, variable which is assigning the root value. What is the root value now? Null is the root value. So this null is the root value. So null is assigned to the temporary. If temporary equal to null, so now it is true, then the data 10, with the data 10, we are created one node, then that 10 is assigned as a root. So now here the null value is replaced with 10. So 10 is my root node. 10 is my root node. So now I have inserted the value 10, which is acting as a root now. Before insertion, there is no node in the tree. Now this tree becomes tree with the root. Tree with root. Okay. So now one node is inserted. One node is inserted. Now second step, I want to insert 20. I want to insert 20. Now again I am passing now values. So now here the root value is passing and data is passing. Data is 20, root value is now 10. Root value is 10 because our root is here 10. So now current node we are again creating, which is null, and now root is the 10. 10 is assigned to the temporary variable. 10 is assigned to the temporary variable. So now we are checking temporary equal to null. No, temporary is having the value 10. Temporary is having the value 10. So here now the 10 equal to null, which is false. So this block is not executing. Now else portion, otherwise, you look at that. So check tree is empty. No, it is not empty. Otherwise, we have to add that root into the queue. So now we will create one queue data structure. So the root is added into the queue. Root is added into the queue. So queue is created. Queue is created with the name of small q. So this is the queue data structure name. Now we are adding the temporary data. What is the temporary data here? 10. Temporary data is 10. So 10 is added into the queue. So 10 is the node which is added into the queue. Now we are performing the level order traversal. Now we are checking queue is empty or not. When queue is not empty, yes, queue is now not empty, which is having the value 10. So now it is true. When it is true, we are accessing the first value in the queue. The first value, first pointer is indicating the 10. Okay, rear is here, rear pointer is this one. So now we are removing the data from queue. So now the 10 is removed from the queue. The 10 is assigned to current underscore node. Current underscore node is having 10. Okay, current underscore node is having 10. Then now we are checking if current underscore node dot left. So this is the current underscore node dot left. Okay, so current underscore node left equal to null. Yes, current underscore node left, current underscore node dot left is null. If it is null, we are assigning the new data value. New data value is now 20. So the 20 is assigned to one new node, right? That is assigned as a current node dot left. What is the current node? Current node is the 10. So for the 10, left node will be 20. After that we are breaking this execution. So this method is now executed. Then now newly I am going to insert 30. Insert 30. So now again I am calling the method void insert of node root comma data. So now the root value is again 10. So 10 is the root value and the data value is 30. So here current underscore node is now null. Then root is assigned to the temporary. What is the root value? 10. So 10 is assigned to the temporary. We are checking temporary equal to null. No, it is false. If it is false, this block will not execute. Otherwise, else block. We are creating the queue. Yes, we are creating the queue. once again we are creating the queue, and now we are adding that temporary value. What is the temporary value? 10. Temporary value is 10. So 10 is added into the queue. Then we are checking is queue is empty or not empty. Not empty. So the condition is true. So now we are accessing the first value in the queue. So the first value in the queue is 10. First value in the queue is 10. So 10 is assigned to the current underscore node. So now we are removing the 10 from the queue. So we are removing the 10 from queue, that is assigned to current underscore node. Current underscore node is now 10. Then we are checking if current underscore node dot left equal to null. You look at that, current underscore node dot left equal to null, which is false, which is false. So this block will not execute. This block will not execute. So else portion is q dot add current underscore node dot left. What is the current underscore node? Current underscore node is 10. Current underscore node is 10. 10 dot left is 20. The 20 is going to be added into the queue. So 20 is added into the queue. So now this is the first value. This is the first value. So then we are checking if current underscore node dot right equal to null. So current underscore node is 10. 10 dot right is null. Yes, it is null. It is the true now. So when it is true, we are passing the data 30. That with 30 we will create the node. That node is assigned into the current node dot right. So current node dot right is 30. After assigning, we are breaking this execution. Breaking this execution. So once it is broken, the program running is terminated. Program is terminated. So now this is the procedure to insert the data into binary tree. If I want to insert one more data, 15. So now again we will pass 10 comma 15 here data. We will check root is now 10. 10 equal to null, which is the false, then it is not executed. So false block is here. Again you will create queue. Again you will create queue, right? So now again we will pass the root value, temporary value 10. We will check queue is not empty. Yes, it is not empty. It is not empty. Assign that 10 into the current underscore node. Then we are removing the 10. Now current underscore node dot left. Current underscore node dot left is 20. So this is false. So we will add the 20 into the queue. 20 into the queue. This line. Then if current underscore node dot right equal to null. So here the right is not null, which is having the 30. If it is 30, the condition is false. Condition is false. If it is false, then this line will execute. Adding the right node into queue. Right node is 30. So 30 is added into the queue. Now again we are checking queue is empty or not empty. Queue is while loop. Okay. So here the while loop here available, queue is empty or not empty. Still queue is not empty. So when it is not empty, we are assigning. So next peak is 20. Next peak is 20. So 20 is assigned to the current node. Then that is removing from the queue. So 20 is available. 20 dot left. 20 dot left is now null. You look at that, 20 dot left is null. So which is true now. If it is true, the new node 15 is assigned into the current node dot left. So 15 will be assigned into the current node dot left. Then the execution is broken. So this is the way to insert the data into the binary tree. Thanks for watching.